This is the beginning of part 2 of our module on structured FRNs, which examines the construction and risk analysis of structured floating rate notes. We remind you that this part 2 contains chapters 3 and 4 of the module, with chapter 3 examining superfloaters and their price sensitivities, and chapter 4 addressing the structuring of more complex instruments that incorporate both swaps and options. This chapter 3 introduces superfloaters, which are in a sense leveraged floating rate notes, and discusses some of their very peculiar price sensitivities. Using prices appearing in the worksheet pricing grid, let's suppose that the investor purchases a $100 5-year FRN issued by the same entity as before, and then enters into 3 swaps with notional $100 each, in which she pays fixed at the normal 5-year swap rate and receives 3-month LIBOR. The diagram that just appeared shows the original FRN bought by the investor, as well as the cash flows under the 3 swaps, aggregating in total coupon terms to, let's see, L plus 3 times the net settlement under the swap, which is 4L minus 3 times the fixed leg of the swap, equals 4L minus 14.31. The name given to this instrument is the superfloater, on account of its leveraged exposure to LIBOR in the form of the multiplier of 4 in the coupon formula. For each increase of 1% in the LIBOR rate, this instrument sees its coupon rising by 4%, allowing its performance in coupon terms dramatically to outperform that of a regular FRN of comparable maturity. But of course the reverse is true as well, meaning that a 1% decline in LIBOR would reduce the coupon under the superfloater by 4 percentage points, which would hurt the investor's coupon and hence its price far more than under a regular FRN. The price sensitivity of the superfloater to changes in rates is especially interesting and unusual. Specifically, rising rates are accompanied by rising cash flows under this note, but also by rising discount rates to apply to these future cash flows. To some degree, these will, of course, offset, but the multiplier of 4 typically means that there will be net price gains when rates are rising and net price losses when rates are falling. The easiest way to see this without building a very elaborate spreadsheet is to recall that we built the superfloater by adding together a regular FRN and 3 5-year interest rate swaps under which the investor is paying fixed. Now we know that the regular FRN has little price sensitivity or duration to moderate changes in interest rates, while we also know that each 5-year swap should have a modified duration of perhaps around 4.3 or thereabouts, and would increase in value from the investor's viewpoint as rates increase. So technically we would call this negative 4.3. Thus, on a net basis, increases in rates will give rise to gains for the investor, and indeed to substantial gains given the presence of 3 swaps in total. Ignoring convexity and assuming that the modified duration is indeed around 4.3, we would therefore expect a price gain on the superfloater of some 13% when rates increase by 1%, and of course the reverse, again if we ignore convexity, when rates fall by 1%. The graph now appearing in front of you plots on the x-axis changes in interest rates from plus 3% to minus 3%, and assuming flat curves at all times, against on the y-axis the price changes as percentages of both a 5-year fixed rate bond, shown here in blue, and the superfloater as we have defined it so far. Note not only the unusual aspect of the superfloater, indeed it is one of the very few instruments in fixed income whose price rises when rates rise, but also the manifestation of the leverage in the far greater steepness of its graph versus the blue representing the fixed rate bond. Our graph for the superfloater, however, ignores the very small price sensitivity of the FRN component that we used to build the superfloater to movements in the short-term interest rates. In practice, you would need to take that into account. There is one problem with the superfloater that we have ignored so far in our discussion, and is in fact a little tricky to solve. At LIBOR levels below 3.58%, the coupon becomes negative in principle, something that is typically unacceptable to the majority of investors. We need therefore to incorporate into the instrument protection against this phenomenon via a 5-year LIBOR floor struck at this 3.58% and presumably with a notional of 4 times the $100 principal of the note, i.e. $400. Note carefully that we said 4 here versus the 3 swaps we had entered into originally to create the desired coupon. Click pause until you are convinced that this is correct. A strike of 3.58% is not visible among the available choices on this worksheet or in any of the other worksheets that provide prices, but all we need to do is go into the cell M5, insert the 3.58% strike that we want, and then the worksheet does the work for us, revealing indeed for a 5-year 3.58% strike floor a premium of 181 basis points, Remember, however, we need to set the floor's notional at 400, so the total upfront premium comes to 4 times this number, or in dollar terms, 7.24. But we find ourselves wondering, how is the investor to pay for this? If we just took out $7.24 from the investor's original $100, she would no longer be able to afford the FRN that she needs as part one of the structuring process. Instead, we will adjust the fixed leg of the interest rate swaps that she enters into so that each swap has a negative initial PV from her perspective equal to 1/3, please note 1/3, not 1/4, of this required $7.28, i.e. equal to $2.43 approximately. Diagrammatically, this is shown in this manner, with the aggregate package still worth $100, we hope, and with the positive value of the bought floors being offset by the negative value of the off-market rate swaps, leading to a 0 PV on the derivatives combined. If we ignore convexity once again and assume a modified duration for the swap of 4.3, we would prima facie need to increase the fixed leg by 243 divided by 4.3, which is 57 basis points approximately, i.e. we would need to lift the fixed leg of the swap from 4.77, the market rate, to 5.34% in order to achieve the desired result. But this would give rise to a new problem, although one that is smaller in magnitude. Let's see. The structured note coupon has now been modified to become L plus, L from the FRN of course, plus 3 times LIBOR minus 534 from the swaps, which simplifies to 4L minus 16.02%. Therefore, the strike on the floor needs, in turn, to be amended to just over 4%, up from 358 previously, on account of this new formula. But this now would also increase the premium for the floor once again, and so on. This process appearing likely to iterate several times before we ultimately converge on one single solution. Let's go on just a little while longer to see how this works, and then we will propose a better and more elegant solution at the end of this discussion. The 4% 5-year floor is seen on the worksheet to cost 275 basis points, up from 181 previously. So given the multiplier of 4, the total value of the floors comes to 11% up front. In turn, this means we need to adjust the original swap fixed leg upward further, so that each swap has a negative initial PV of 3.67%, which means increasing the fixed leg by 367 over 4.3, which is now 85 basis points, up from 57 basis points previously, and therefore all the way up to 5.62%. The notes coupon now becomes 4L minus 16.86. You can confirm. Which means the floor's coupon must be adjusted a third time to 4.21, increasing the premium to 3.27%, and therefore the aggregate premium to this 13.08 that you see here. Again, we allocate this among the three swaps, 4.36% each, and we derive a fixed leg adjustment of 436 over 4.3 equals 101 basis points, i.e. 5.78% all in. Now, the shift in the swap rate with each iteration became visibly smaller each time. So why don't we skip a few steps and go to what the author of this e-learning module knows to be the correct answer, 6.08%. If we continue to ignore convexity and to assume a modified duration for such a swap of 4.3, we can confirm that this works. Under our final structure, the investor buys an FRN, then of course enters 3 5-year swaps, this time paying 608 fixed against LIBOR, which gives her an all-in coupon of 4L minus 18.24%, which indicates the need for the 4 floors to be struck at 4.56%. These would be costing 422 basis points each according to our worksheet, so a total of 1688 basis points as you see here. Now turning to the swaps, however, these are off market by 131 basis points each. Therefore they have a negative fair value of 131 times modified duration times 3 swaps, which is 1689 in aggregate basis points. The PVs have indeed converged. All this has been terribly tedious, of course, so in the quiz question at the end, we will provide you with a worksheet that prices floors and swaps and ask you to program it further to enable you to derive the exact solution to a problem of this kind simply using the goal-seek operator. For the time being, however, our discussion of superfloaters has come to its conclusion, and with it, the end of this chapter 3.